Okay. All right, so fraction buster. I have 3, 9, and 6 in the denominator. What number does 3, 9, and 6 all go into? 18. Beautiful. And fast. Okay, step 1, find the least common denominator. Step 2, multiply all of the numerators. I already see where I might need my calculator for 18 times 19. Unless any of you did this problem already. You can tell me what 18 times 19 is. Okay. All right, so I have 18 times n, 18n minus 18 times 1 is 18 over 3 equals 18 times 19, 342. I feel like I should know that somehow. Minus 18 times 5, 90 over 6. All right, any questions about step 1 or step 2 on a fraction buster? You good? You sure? Okay, do you remember what step 3 is? Perfect. Divide the numerator by the denominator. And if we did it right, that means that these should all come out magically to whole numbers. 18 divided by 3 is 6. Okay, what do you guys want to undo first? I want to undo negative 15n, but I guess it doesn't matter. Whatever you want. Okay, I'm going to reduce this. I love this one because it's kind of obvious what goes into both of those. 11. Okay, so I'm going to go like this. Okay, however, right now is going to be your first lesson of your graphing calculator. If you have your graphing calculator, get it out. If you don't have one, you can come grab one over here from under the window. I'm going to teach you right at this moment one of your favorite graphing calculator lessons of the year. I promise. Okay, first, if you've never had one of these before, the on button is down at the very bottom left. So make sure to turn it on. There might be stuff here that previous people did. You can hit the clear button here over here underneath the arrows to clear that out. This very well might be your favorite graphing calculator lesson of the year. Okay, we are going to take 44 divided by 33. So do 44 divided by 33. 44 divided by 33. And then hit enter. You see how that is unsatisfactory for this problem? According to the Vegas rule, it's not really a rule, I just made that up. You're supposed to leave your answer in a fraction. Your calculator is smart enough to fix it for you. So you're going to go math, hit the math button. It's right underneath the green one. Math, enter, enter. Oh. Math, enter, enter is going to be your new best friend. It will change all of your gross, ugly, unsatisfying decimals to beautiful, satisfying fractions. Math, enter, enter. If you say nothing of dinner tonight, like go home and your parents are like, what'd you learn today? You'll be like, I learned about math, enter, enter. And my teacher basically told me that I don't even have to think about changing decimals to fractions anymore because we're not doing that in math 3 most of the time. We are learning algebra. But anyway, do we like it? We like it? Math, enter, enter? Okay. All right, now, square root of 18. Unfortunately, for you, these lovely graphing calculators will not simplify square roots for you. So you actually need to think about this one. Okay. What multiplies to be 18? 9 and 2. And I really like that you chose 9 and 2. You might not have chosen that on purpose, but there's a good reason to choose 9 and 2. That's because, yeah, you did know. So the 9 is a perfect square, which will get your twins of 3s right next to each other. So I found my pair, circle, cancel. Circled one on the outside, left over on the inside. Circle outside, left over inside. All right, flip to the domain and range page, please, when you're ready. You're all like, Mrs. Talbot, why didn't you do that one yesterday and the 252 today? Because that one was way easier than yesterday's. It's just how CUDA prints them out. Look at the draw. Okay. All right, now I'm going to ask you to engage that part of your brain where you're understanding that this is hard and you're still learning it and it's okay. All right, domain is the X. I'm going to deliberately put an X on the X axis and I'm going to mark up the X axis. Okay, it looks to me like this side has an arrow that goes forever. So I'm going to follow that this way. And my graph still exists here, and my graph still exists here. And then it looks like it has an arrow that goes forever also to the right. This graph covers the entire x-axis. What do we put when the whole thing is included? All real numbers. Okay, I'm going to put a y at the top of the y-axis, and I noticed that I have an arrow going up forever, so this part of the graph exists forever, goes forever down. All this stuff in the middle is covered. Whole y-axis is covered. That is all real numbers. Okay. And as I said, the thing about being a function or not being a function is going to come to you really much faster than the domain and range. Is this one a function? Yes, because you can draw vertical lines all through this and only hit that curve once for each. And it is continuous. Continuous meaning it's a curve that goes on forever in both directions, and I can draw it without picking up my pen. Okay, number 4. Domain reminding you is left and right. Does this graph go on forever to the left? Yep. Forever to the right? Yep. Is the whole x-axis covered? Yep. What do we call that? Nice. You're like, I'm sort of, kind of getting it, sort of, kind of. But don't give me a different one because I'm not going to get that. But this one, I sort of, kind of get. Okay. Now, the y, the range on this one is only one spot. There's only one spot for the y, and that is 3. Vertical line test. Does it pass? Yes. And this is also continuous. Okay, now can you flip to the homework, please? That was the Math 1 and 2 review worksheet. Does anyone have any questions about this worksheet? Anything that you could not figure out, you got absolutely stuck and the solutions did not help you? Anything you want to ask me about the Math 1 or 2 review worksheet? Any questions? All right, you sure? You're positivo, okay? I will be here if you like are nervous to ask in front of class. Just hopefully at the end you could come ask me if you want to, but I'm here for you. Okay. Let's look at my super fun agenda that I made. So we're going to do 2 problems today. The first problem is more domain and range stuff. The second problem is a square root function investigation. So you guys know some functions already. We've talked about lines, we've talked about parabolas, some with factoring. You probably you haven't grasped the square root function before. You're actually going to make a poster in your groups, arts and crafts, but you're not going to finish it today. I'm going to give you more time to finish it tomorrow. So just to let you know, homework tonight is the chapter 1 quiz review. And if you take a look in your packet, if you flip, there's a quiz 1 review right after the answers are provided. It is exactly the same topics as the quiz. You guys remember the topics? Anybody remember the topics? There's 3: factoring, graphing a line, and solving a 1 variable equation, which is just like, distribute and solve for that. Also, here's my daily joke. So this is a law firm that's Allen, and it says when you do all the work in a group. You get it? This is just you. Hopefully that won't be ever the case in your group. Okay. Alrighty. Right, if you guys could get your notebooks and start setting up number 12. So if you notice right here, I've got yesterday, so just keep going on the same paper. You can just right underneath. All right. Hopefully that was enough time. Okay, so these problems are kind of backwards. So number 12, A and B, they're backwards. So remember the warm-ups, they gave us a graph and we found the domain and range. These two, they want you to be creative and they gave you the domain and range and they want you to make a graph. Okay, the easiest way to do this, I find, is to number my axes with the domain and range they gave me. So I'm going to take a straight edge, and you guys can use a straight edge if you want. I'm a nerd, so I'm going to use it. I made it this size because I noticed that the domain goes -3 to 10 and the range goes -4 to 6. So I didn't want to put my origin directly in the middle. Okay, and what I'm going to do is I'm going to count out the domain. The domain goes from -3 to 10. And the range goes -4 to 6. Okay, so I want you to picture in your mind, mental picture, what kind of graph could I make that would fit inside of these marks that I made. And you can do pretty much anything. You could make it curvy. You can make it like a wavy thing. You could make like a U shape. You could make steps. You could make anything. I'm a lazy human being. Do I have any other lazy people in here? Just one person is admitting to being lazy with me? I don't know. I feel like some of you. Okay, how about let me rephrase it. Anyone else in here super efficient? I like to turn the word lazy into efficient. The most efficient way to do this problem is to go from corner to corner. So picture this being like a rectangle. Start in that corner and go to that corner. Oh, does it have to be this direction? No. But I want you to know there's infinite possibilities. This is just the lazy way. Notice I do have my closed circles, so I can tell. So let me ask you this. Does my segment that I made here go from -3 to 10 on the X? Yeah. And does it go from -4 to 6 on the Y? Yeah. Okay. Again, you can make a squiggly. You can make, anything. Okay. B. I'm going to set up my scale of my graph a little differently on this one because I noticed the range values are all positive. And this one's going to be a little harder to imagine. I want you to try to talk in a group brainstorm for just 30 seconds. What type of graph would this have to be to have a domain of all reals and a range of only 2, 4, 5, and 8? This is a really hard question, so if you don't get it, I totally understand. Domain of all reals, range of 2, 4, 5, 6. would that even work is an excellent question. This is really hard. Excellent. Okay, it's not dots. Yeah. But your thought is beautiful. So it's not dots. I mean, yeah, you can do an infinite number of dots, I suppose, but we don't like that. Okay. I heard someone actually say it. Someone got it. Someone in this room spoke the correct answer. I heard them say it. And does anyone feel brave enough to venture a guess? It can't be just, well, okay. It's not that it couldn't be just dots. It could be just dots if you feel like drawing dots for the rest of your life. So if you're, up for, aging, turning into a skeleton, drawing dots. Yeah. Is it like a piecewise function? It is a piecewise function. Okay. However, we need to be more specific than that. What type of piecewise function? It has to do with things that you have to use to get from floor to floor. Yes. It is a step function. Okay. And what I heard someone say was, would it just be lines across? And that is true. It would just be lines across. Now you could make these to satisfy this. You could make these all 4 lines, except for then it wouldn't be a function. So what we're going to do is we're going to do steps. You can do steps going down. You could do steps going up. You could also do steps that alternate heights. It doesn't matter, but I'm a linear thinker, so I'm going to do steps going up. So for example, I'm going to do something like, and I'm just making this up. Every single one of these I do today in all 3 of my classes are going to be different. So I'm going to start with a step at the 2 spot. And that's going to cover me from here, whatever this is, to negative infinity. Then right above that, I'm going to put an open circle. Does anybody know why I did that? To connect it, but keep it a function, right? Because I don't want it to fail the vertical line test. I'm just going to go to a random spot. Random spot. I realized I had to make that one short because I was running out of room. Does it have to look exactly like that? No. There's infinite possibilities. They don't need to go from low to high. It's totally fine if they don't. I'm a linear person, so I like to go from low to high in my brain. Okay, if you guys could set up your notebook for number 13, also make sure you've got that calculator on you when you use the calculator for making the table. So as I said, for number 13, you're going to make a poster of a square root function in your group, but I'm going to demonstrate one for you first so that you have some idea of what you're doing before you start to make a poster. Is that the table squeaking? I need to WD-40 the table. Yeah. Luckily, my husband is an extremely handy guy and he'll come in and fix that. Welcome to public school furniture. Okay, we're going to do 3 things here. We're going to make a table. We're going to use our calculators to make the table. We are going to sketch the graph off of the table with the coordinate points, and then we're going to describe the graph. And this is exactly what I will expect you to have on the poster. Okay, so I'm assuming most of you have never graphed a square root function before. unless you're repeating this class, then you may have done it then. Or unless you took some kind of, fun math over the summer or something, maybe you did. Okay, what we're gonna do is we're gonna make the table on the screen here. So I'm gonna plug in -5 in for X like a function machine, 3, and then let me show you how to get the square root. You need to find the button that has X squared on it. And you should notice the little square root is above it in blue. Okay, so here's the squared button, and the square root is right above it in blue. Everything on the calculator that's in blue, you need to hit the blue button first. And you guys should have some idea of that from your old calculators. Even the scientific ones have that. So I'm going to hit 3, and then second X squared. If you have an older calculator, it's not going to put this underneath here like this. It's going to put a little parenthesis. Okay, and then the X button, we have it, but we're not going to put X. We're going to put -5 in for X. So -5 plus 5. So I took my -5 and I put it in there. Plus 2. Make sure that you arrow out using this arrow to get out from underneath of the square root. If you have an older calculator that does parentheses, end your parenthesis after the +5. And you should get 2. Did you get 2? Okay. Okay, now, anyone else lazy? Just checking. Just me, one other person lazy. Okay, what you're gonna do is you're gonna cheat, and you're gonna use the scroll button to scroll up and highlight this one. And then you're going to hit enter, and it's going to copy and paste it for you. And you're just going to scroll over and change that to a 4. I know. I just made your life easier again. Math, enter, enter, and the copy paste. Okay. Can you guys finish the table on your own? Does anyone need assistance? I will walk around and ask if anyone got stuck. Is it because you're putting minus instead of negative? The negative is at the very bottom. Check to make sure if you're getting an error that you do minus instead of negative. Oh no. Just round it to 24. There's going to be decimals once you get to the -3, by the way, you're not wrong. First, +2, enter. And scroll up. No. Calculator is this on? What did you guys hear me about that too? So you're putting everything on the +2 is the other outside. See on the arrow outside, and then you check that. If that's not it, I'll be right back. Good job helping each other. I saw this one was 6.24. Can somebody give me the next 4 super fast so we can move on? What's the -1? 8, 0, 1. 9 point what? Okay, thank you so much. Just for speed purposes. Thank you. Okay, so let's graph these coordinates. Alrighty. This is actually what this graph looks like. Now, I want to show you something real quick. What happens if I keep going? What happens if I put in -6? And you guys have some knowledge of what would happen if I put in -6. I started at -5 for a reason. What would happen if I put in -6? It says error, non-real answers. What kind of numbers are not real? Imaginary. Okay, and we can't really graph imaginary numbers yet. You can in pre-calc, but not yet. So this is actually what this graph looks like. Okay, so we're going to fully describe it, and then you guys are going to get started on your posters. So I'm going to give you a different one to do in your groups. You're going to follow this exact same procedure as a group and make a poster out of this graph. The type of graph is called a square root. You can tell what type it is because it's got a square root in it. Okay. Shape. Square root graphs all have the same shape. And if I were to flip this down here, if that were to work, it would be a parabola. You guys remember what a parabola is? However, the parabola fell on its side. So this is half a parabola on its side. So when you guys graph yours on your poster, you should get half a parabola on its side. They'll all be the same shape. You don't even have to think about it, but you can use that to check to make sure that your math looks good. Okay. The domain is going to be everything from here that way. So starting here and everything this way, remember we mark up the x-axis. So this is x is greater than or equal to -5. Can you also tell from the table that x is greater than or equal to -5? Look at all the numbers in the x column. Okay, range. Lowest spot is here, goes up forever. Y is greater than or equal to 2. Can you guys tell that y is at 2 and going up forever on my table also? Okay. Yes, this is a function. vertical line test. And the last thing we're going to include is that it is increasing, meaning that as I go from left to right, my graph is going uphill. Okay. I'm gonna bring you guys. Okay, so I need you guys to get 3 things, and my super helpful TAs have been holding on to this stuff for a while here. These are my TAs, and I love them. They're very helpful. Okay. I need each of your groups to get one of these giant sheets of graph paper that I cut out, a box of markers, which I'm going to move over to this Manny clinic, and a ruler. So if you guys could send one person per group up to get big piece of paper, markers, and ruler. Going to have the hardest part about this whole thing is going to have to figure out how you want to scale your graph, I think. So it depends, each one is different. Okay, now whoever has nice handwriting, grab one of the markers. Nice handwriting, nice handwriting. Okay. All right, and listen very carefully. This is the only part that you need to listen to really until you finish this problem. Okay, we have a bunch of different ones here. I want groups 1 and 5 to be this one. So table 1 and table 5 are going to do I. Does that make sense? Okay, so right at the top of your thing, right in. Okay. Table 2 and table 6 are going to do I. Table 2 and 6 are going to do I. Table 3 and 7 are going to do IV, which is 4. So little baby Roman numerals. Okay. And then group 4 and 8 are going to do number 6 here, DI. Okay, however, really quick, for 4 and 8, just lock eyes with me for a second. There's a negative in the front of this. Just make sure that you're careful with that in your calculator. And yours is going to look a little bit different from everybody else's. Don't freak out. It's because of that negative. Okay, just give me a heads up. Anyone need to repeat which one they're doing? Okay, while you guys are working on your poster, do you know what the requirements of the poster are? Table, make a table using the calculator like you guys did. Sketch the graph, try to make it pretty, and then fully describe like we did on number 13. Okay, I'm also going to give you more time tomorrow to work on this. You might finish it today, I'm not sure. While you're working on this, I'm going to come around and stamp as much as I possibly can that you have stamped. For the first 2 minutes, I'm going to go over and see who has submitted the digital escape electronically first. So I'll be around. If I don't get to you, don't freak out. I'm going to stamp at the beginning of tomorrow also. But remember, if you're not done with something, just say, not yet. Put that nice word yet for me. Do you know what I'm hanging up on the whiteboard up in
I don't remember anything from these parts right here. I don't remember. Is that how you do the quad formula? I don't remember.
Yes, the square root goes over the whole thing, and there's a plus or minus here. You might want to YouTube.
Okay.
Quad formula.
Okay.
It's not on our quiz tomorrow, okay. So it's not a huge deal. This is equal values method. Okay. So you equal those to each other and then solve for x and then plug it back in.
Okay. I know this one's substitution.
substitution, but yeah, so you're gonna take the x plus 3 and put it in the spot where the y is.
Yeah, I just don't. What's this one again?
Elimination, so you're gonna multiply the top by 3.
Okay.
That's gonna give you a positive 12y and a negative 12y that will cancel.
Okay. Thank you.
I know, it's rusty.
Yeah.
But I'd rather you like finish it slowly and then like give it to me when it's done.
Okay.
But I will just keep helping you.
Okay. Thank you.
Oh yeah. There's one over on the table under the window too. Okay. Now, who did the digital escape? By the way, it was you who said the lines